Hi, I'm Adam Pease, and today I'm going to talk about the model view controller paradigm and how it applies to ontology. So first, what is Model View Controller, or MVC? Essentially, it's a programming paradigm or a design pattern that was developed quite some time ago, originally at Xerox PARC, and then originally embodied in the Smalltalk language. It's a language that I feel a great affinity for because it was actually the language I started with in my first job as a new programmer out of college. Really beautiful language, a lot of great ideas that were way ahead of its time. And one of those was this model view controller idea. But however, now this is really common in most modern languages. Python and Java also have a version of the model view controller paradigm embedded within their libraries. So what is this exactly? It's an idea that software that has a user interface should ideally be divided into three parts and that are kept as modular and separable as possible. So there's a model, which is a representation in data in some set of data structures. It's a representation of the real world, the thing that you're trying to model, the thing the program actually cares about. Then you have a view, which is one or more presentations of this model to the user. It could be tables, it could be graphs, it could be windows and menus, all sorts of different things that programmers build every day. And then there's some sort of controller, a way in which the user interacts with this model to get some kind of job done. So the view displays the model to the user. The user then manipulates the controller to affect changes in the model, which are then rendered in the view, and the cycle repeats itself. So pretty nice, simple, elegant concept. And the beauty of this is that if it's done right, if these three modules are kept quite independent of each other, if you have modularity in your software design, then this sort of decoupling allows us to then have different views and different controllers that are suitable for different users or different contexts of use or solving different problems, but all can have the same model. And this is very powerful. It's a great way to have very reusable modular software if you can think in this way. So another way to look at it is you can have extremely powerful interfaces like a sort of control panel that I'm showing here for some set of users that are highly expert maybe in this particular domain that this program is addressing, and others that's maybe just an on-off button. That would be the ultimate simple interface. You've got yes and no or off and on. Presumably you want your interface to do more than that, but taken to its limit, you can have a very, very simple interface and a very complex interface operating on the same model, presumably also with different controllers. But these things are interchangeable. You can also have essentially the same interface, the same view of things, the same number of controls or complexity of controls with different controllers. And we're all now familiar with the fact that you can have a windows and menus and text-based interface, or maybe you have a voice interface like with Alexa. Drastically different controller, a different view, but ultimately probably the same model. So power and complexity go hand in hand. A powerful interface may require experts, but those experts will in turn have very few or a small number of restrictions on the changes they can make to the model. Whereas if you have a highly simplified interface, there's a natural limitation on the number of things that a user can do. And if you design this correctly, appropriately, that's a good thing. You want the different users in their different contexts to have a degree of power and complexity that's commensurate with the objectives that they have or that you want them to have as the designer of the software. So how does this apply to software? How does it apply to ontology? We've looked at generally in software. So a powerful ontology can have a very simple interface. It can have a very simple view while maintaining the same model. And so for all of the industrial projects that I've done over the past couple of decades, many of them are really just a variation on this theme. A powerful expressive ontology, but a simple interface that is often some version of a spreadsheet. So here's an example of where you might have a catalog of medical devices. So it has some different things that are for sale, such as oxygen tanks or hypodermic needles. They have a number of attributes to them. And using a spreadsheet, and you could do this in any sort of spreadsheet system, like Microsoft Office, for example, you can have your domain experts as well as your data entry professionals fill out this spreadsheet and neither know nor care that they have an ontology in the background. As long as they name these relationships in a reasonable and consistent way, and then they fill in the data, they can get their job done. Now, when you couple this to an ontology, you can generally have a very simple script. I actually have a default implementation of such a script in the open source Sigma ontology environment that I release on GitHub that just converts these simple relationships in the spreadsheet into tuples. Tuples like a database, and these are easily expressible in the powerful ontology language that I use. They coexist with the complex relationships and constraints that are in the Sumo ontology. Now, in such a simple table-based interface, those users that are just dealing with tables don't have access to these constraints, but the constraints can still help them. They can be still there to read as a data dictionary. They can also provide integrity constraints on the data that's being created in this simple format. So the definitions in the ontology are constraints that help keep the data consistent. They're suitable for data hygiene or data cleaning applications, or different sorts of names for this sort of function. And they also function as a data dictionary. Your standard data dictionary is usually just text if it's present at all, and having an authority, a standard for what these relationships are supposed to mean is incredibly important in having good, clean, consistent data that can have a long life. So anyone that's concerned about having a complex expressive ontology in a difficult logical language, just think about how you can keep these two things separate. The interface that most people will have to deal with, and then a powerful representation in the background that can be used to help keep the simple relationships consistent. So in the same way as you don't need to have every person on your data entry team be a programmer, you also don't need every person on your data entry team to be an ontologist versed in mathematical logic. So this way you can get the best of both worlds. Have an interface that is appropriate for the people that are on your team and the objectives that they have with the system and with the data and so forth. So I hope this has opened your eyes a little bit to the notion of model view controller and how it can be applied to ontology. There's a lot more information on the links here, a lot more related videos, so please like and subscribe, and hope this was helpful for you. Thank you.